Hello everyone, this is Dr. Saeed Falafini from Cal Poly Pomona. In this video, I'm going to talk about the second set of actions that should be performed in preliminary design phase of a system's life cycle. As you remember from previous video, we talked about the first set of actions, which was related to understanding the requirements and trying to get a very clear definition of the requirements and expectations from the system. Now we are going to focus on the second set of actions that should be performed in preliminary design. The second set of actions is related to defining the functions and actions that should be performed in the system so that it can achieve its objectives. So just to give you an example so that you can get a better sense, let's go back to the bike rental system example. The mayor of the city of LA has asked you to design and implement a bike rental system in LA. And if you remember, one of the requirements that we specifically talked about was that we want the chance of accidents with the bikes in this system to be close to zero. So the chance of breakdown and accident with these bikes should be close to zero. So how we can make sure this requirement is going to be achieved and accomplished? Obviously, one set of functions or actions that we should definitely perform in this system is related to the maintenance of these bikes. So if we plan properly and if we maintain our bikes frequently, then we can definitely reduce the chance of breakdown and accident with our bikes. So the requirement related to high safety and almost no accident and no breakdown of our bikes can be accomplished by performing the set of actions or functions related to maintenance of our bikes. So this is how we are going to relate our requirements to the set of actions that should be performed in the system so that we can make sure we achieve those requirements. So the set of basically the whole process that we go through to define this set of actions or function is called function analysis, and this is usually a top-down approach in terms of extracting the set of actions or functions. And so by that, again, going back to the example of the bike rental system, I mean, if we say that, okay, performing maintenance or maintaining bikes is the function that we are looking at, there are a set of lower level functions or actions that is inside the high level function of performing maintenance operations. For example, when I say performing maintenance operation, that includes so many things, such as hiring people who can perform maintenance operations, ordering and receiving spare parts, performing the actual maintenance operation itself, and then also finding a way to get rid of all those defective items that we may end up with after performing maintenance operations. We can even go further down into the detail and say, okay, performing maintenance operation as the second level action that we define inside it, we can define even lower level functions such as performing diagnostic tests, removing the part that needs maintenance, adding newer parts, and so forth. So with this example, I'm trying to just show you that what do we mean by using a top-down approach to define the set of functions that should be performed in the system. And so again, going from the high level performing maintenance operation to lower level functions or actions that should be performed inside these higher level functions. And I need to also emphasize the fact that as we talk about function analysis, we talk about the functions or actions that should be performed. What should be performed in the system, and we are not going to go into the detail on how they should be performed. So the function analysis focus is what should be done and not how it's going to be done. And as we perform or try to define the functions that should be performed in the system, we may need to revisit and refine some of our requirements For example, we may find that some of our requirements have not been really defined clearly, so we cannot define the functions that should be performed so that those requirements are achieved. So that forces us to go back and refine our set of our functions as well. And this is very helpful because, which basically means that defining requirements and the functions that should be performed to meet those requirements is pretty much an iterative process, and we may go through this iterative process a couple of times till we finally refine and complete the set of requirements and also refine and complete the set of functions that should be performed to meet those requirements. And at the end, we have a set of functions that should be performed in the system, and also we need to also specify how well those functions should be performed. That would be the outcome of functional analysis. So a tool that we can use to basically specify the set of functions and also to put them in a setting so that everyone can understand how these functions or set of actions are related to each other is functional flow block diagram. It's a very helpful tool that helps you to basically draw and put together the set of all functions in a system so that you can understand them clearly and not to get confused with the large set of functions that you may define for a system. So this is a schematic representation of a functional flow diagram. The set of, so as I said, it's more functional flow block diagram or function analysis is a top-down approach, meaning that we initially define the high-level functions or actions that should be performed in the system. And here, those are the functions that we have specified in the first row. We usually in functional flow block diagram put the functions or actions in squares. On top of these squares, we put the number of these functions, and inside these squares, we usually put the title of these functions. For example, performing maintenance operations, and so forth. And we usually use arrows if there is a sequence between these functions. If one function should be performed before we perform the other actions, we can use arrows to show this sequence. And if there is no specific sequence, we don't need to put any arrow between those functions. So after we define the top level functions, for those functions that have more detail inside them, we can go into lower level detail and perform all those detailed actions that should be performed inside them. So that brings us to the second level functions. For example, here, if function f1 has a lot more detail inside it, we can come to the second level. I put function f1, which is my reference function, that's the one that I'm going to talk about. And then I can go into more detail and specify what's happening exactly inside function f1. What are the detailed actions that are performed inside function f1? And in terms of the numbering, if function f1 is defined by 1, I'm going to number the functions that are performed inside f1 as 1, 1, 1, 2, 1, 3, 1, 4, and so forth. And I'm going to write the title that each one of the functions have inside the square associated with them. And at the end, I'm going to put the other reference function that finishing the function f1 will lead to. So as we finish function f1 and everything that is going to happen inside it, we will reach to function f2, which is my reference function that happens here on the top. Okay, so in the second level, we can go into the detail of those functions that are high level and have more detail inside them. And again, we can just continue this to as many levels as it's needed. Let's assume function f14 here has more detail inside it. So we can specify those as well. So that would be my third level. Function 14 is my reference function that I'm going to explore. And then inside it, I will have 1 for 1, 1 for 2, 1 for 3, and so forth. And again, as I finish one function 1 for 1, 4, I will go into function 1, 5. That would be the function that is coming here, and that would be my subsequent function, reference function. And again, going down, if function 1, 4, 3 has further detail, I can just come back to the fourth level and provide further detail in terms of what actions are performed inside function 143. And again, some of these functions may just go down into one more level of detail or two more level of detail. Some of these functions may go into 4 or 5 level of details. That depends on the functions that we define and how much more detail is involved in that function. And a couple of other things that we need to pay attention to in functional flow diagram is that sometimes, for example, in this scenario, we may perform function 1, but after that, there are 2 operations that are performed, and we can perform any one of these. We don't need to perform both of them. Any one of them can be performed. These are what we call alternative functions. And if that happens, we can use OR to specify that any one of these functions can happen. We may also have scenarios in which after performing, for example, function 1,4, we have to perform function 1,5 and 1,6 in parallel. They should not necessarily perform in sequence. We can perform these 2 functions in parallel before we can proceed with the next function. We can specify those with AND, which basically means after 1,4, both 1,5 and 1,6 should be performed. And then after performing 143, this is a scenario that maybe after performing one function, we may come up with some options depending on the result of this function. We may go through this path or through this other path, go or no go decisions. And again, if that happens, we can specify those in function flow diagram as well. So as I said, this is just a schematic representation on how a function flow diagram will look like. So in this slide, I'm going to go through one example, and I'm going to read for you some of these functions so that you can get a better sense. So this example is related to lawn mowing, and so the first level set of functions that should be performed so that we can achieve this objective is prepare for lawn mowing, start the mower, move to the mowing area, perform the mowing operation, then move to the cleaning area, perform the cleaning operation, and then store the mower. Okay, so these are the top level functions that should be performed so that the whole mowing operation is done. And now let's assume we want to go into further detail of some of these functions. When we say prepare for mowing, what is included in this function or action? So prepare for mowing is my reference function, which is function 1, and then I'm going to specify the detail function, which is inside function 1 by 1, 1, 1, 2, 1, 3, and so forth. So what is inside preparation of function? Uncover the mower, and then a set of functions should be performed in parallel, but all of them should be performed before we move forward. What are those functions? Visually inspecting the mower, checking the gasoline, checking oil, and then checking the filter. Once these functions are performed, we are going to position the mower at the right location, and then again 2 other operations should be performed in parallel. One of them is controlling operate control, and the other one is inserting the ignition key. After that, 2 other operation functions should be performed, turning on the ignition key and then verifying the voltage. And then once we do all of these functions, we have finished the whole preparation for mowing operation, and then we can go ahead and start the mowing operation, which is my next reference function. And we can just continue this and again pick each one of these functions and go into further detail. But the idea here was just to give you an example on what do we mean by defining the set of functions that should be performed. If there is a sequence between them, specify them. If there are functions that have further detail and action inside them, we can specify those into second, third level functions.